All right, let's get right into it. When we look up at the sky, we see our sun, and we think of warmth, of life. It's this constant, reassuring presence, right? But what if I told you that calm face is hiding a reality of almost unimaginable power and, yeah, violence? And for most of human history, that's pretty much all it was. It was just this reliable light in the sky. It comes up, it goes down. It gives us our seasons, it gives us daytime, a simple, predictable star. Because the truth is, our sun is anything but simple. It is a churning, chaotic nuclear furnace. So today, we're going to go on a journey from the inside out to uncover the sun's violent and absolutely vital secrets. To really get a handle on the sun, we have to start right at its heart, the core. This is where all the magic happens, where all the power begins. It all comes down to a process that fuels not just our star, but every single active star in the universe. And that process, it's called nuclear fusion. At its core, it's all about taking really small things like hydrogen atoms and, under just incredible temperature and pressure, smashing them together to create something bigger, like helium. The amazing part is that this whole process is unbelievably efficient, and any leftover mass gets converted into a truly staggering amount of pure energy. It really all happens in this kind of simple three-step dance. First, inside the sun's core, you've got atomic nuclei moving so incredibly fast, they actually overcome their natural instinct to push away from each other. Then, step two, they combine. They fuse into a new, heavier nucleus. And finally, in that last step, a tiny bit of leftover mass gets converted into this huge burst of energy, which then starts its very, very long journey to the sun's surface. So after a journey that can take, get this, thousands of years, that energy from the core finally makes it to the visible surface. But it doesn't just arrive peacefully. It gets tangled up with the sun's incredibly powerful and chaotic magnetic fields, and that creates these massive temporary storms that we can actually see from here on Earth. We call these storms sunspots, and they look like dark patches for a simple reason. They're actually cooler than everything around them. But why? Well, the sun's magnetic field lines get all twisted up and they burst through the surface, basically putting a temporary lid on the flow of that superheated gas, the plasma, coming up from below. And this creates this really stark contrast. You've got the regular solar surface, which is just blazing hot and bright. But right in a sunspot, that super intense magnetic field, it kind of acts like a refrigerator, making the area cooler. And because it's cooler, it looks darker to us. It's a visible sign of this invisible magnetic battle that's just constantly raging on our star. And these magnetic storms, they are enormous. A large group of sunspots can stretch across 160,000 kilometers. Now, that's just a number, right? It's almost impossible to really wrap your head around what that means until you realize that you could line up more than a dozen Earths side by side, and they would still fit inside one single large sunspot. I mean, that just shows you the sheer mind-boggling scale of the forces we're talking about here. And here's the kicker. This is why they matter so much. Sunspots aren't just some cool dark patches on the sun. As this quote points out, they are the breeding grounds for the absolute most powerful explosions in our entire solar system. All that tension in those twisted up magnetic fields around the sunspots, it has to go somewhere. It has to be released. And when it finally lets go, it unleashes an eruption of energy that we call a solar flare. The best way to think about it is like twisting a rubber band, tighter and tighter and tighter until it finally snaps. A solar flare is basically the sun's magnetic field snapping. It releases all that pent-up energy in this one brilliant, violent flash of radiation across the entire electromagnetic spectrum. And these explosions aren't just random flashes of light. They actually have a distinct life cycle. It starts with a precursor phase, like a little warning shot of energy. Then you get the impulsive phase. This is the main event, where particles get shot out at incredible speeds. That's followed by a gradual cooling phase, and sometimes a really mysterious late phase that scientists honestly are still trying to figure out. It's a puzzle we haven't quite solved yet. But the sun's influence isn't just about these huge, sporadic explosions. Nope. Beyond all those dramatic events, it's also constantly, breathing. It's always sending out this steady stream of particles that fills the entire solar system.
This stream comes from the sun's outer atmosphere, which is called the corona. And the corona is a fantastic mystery. For some reason, it's millions of degrees hotter than the surface right below it, which just seems to defy logic. Scientists are looking into things like constant nanoflares or waves of energy, but what we do know is that this extreme heat gives particles enough of a kick to escape the sun's immense gravity.
And that escaping stream of particles, that is what we call the solar wind. It's a nonstop flow of charged particles, mostly electrons and protons, that just radiates outward from the sun in every direction, and it carries the sun's magnetic field right along with it. And look, this is not some gentle breeze we're talking about. The solar wind is supersonic. It travels at speeds between 250 and 750 kilometers per second. That is so fast that it can get from the sun all the way to us here on Earth in just a matter of days. Okay, so we've got giant magnetic storms, massive explosions, and this constant supersonic wind. The big question is, what does all of this solar activity actually mean for us, way over here on our little blue planet? Well, here's how it all connects. That intense radiation from a solar flare, it can seriously mess with our shortwave radio communications. Those particles from the solar wind, they get guided by Earth's magnetic field, and when they slam into our atmosphere, they create the beautiful auroras, the northern and southern lights. But that exact same interaction can also trigger geomagnetic storms, which are a real threat to our power grids and our satellites. So you can see why understanding and trying to predict this solar weather isn't just some academic thing. It is absolutely crucial for protecting our modern technology-driven world. And it's also a pretty humbling reminder that everything we see happening on our sun is happening on stars all across the universe. So when you put it all together, that peaceful, steady image of the sun that we started with, it just completely falls apart. It's not the real picture at all. Instead, what we have is a star that is deeply, deeply complex. It's a dynamic engine of fusion, magnetism, and raw power that both creates the perfect conditions for life and, at the same time, holds the potential for technological chaos. And that's really the ultimate paradox, isn't it? Our star is both our creator and a potential destroyer. And that leaves us with a really profound question. In this modern age, where we are more vulnerable to its power than ever before, how do we learn to live alongside such a beautiful and sometimes violent neighbor?